Welcome back to Security and Privacy in Cloud. I'm Jay Lavanya, Assistant Professor of CSE Department. So today we are going to discuss on the Unit 5. The topic is that monitoring, auditing and management. So tamper proofing audit logs as well as quality of services. So what does mean by tamper-proofing audit logs? So tamper-proofing audit logs involves implementing measures to ensure the integrity and authenticity of the audit records to prevent unauthorized modification or deletion. So this can be achieved through encryption, digital signature, access control, and other techniques to detect and prevent alterations. And so these are the logs that are designed to prevent some unauthorized changes and guarantee the integrity of the recorded events. Okay. So, so what are the common ways to make the audit logs tamper proof is that write one storage. So saving the logs to media that can't be rewritten. Example like warm drives or immutable storage and cryptographic signing, like every log entry is hashed and signed. If someone changes even a character, the signature won't match. So hash chain, each log entry includes a hash of the previous entry like a mini blockchain tampering which breaks the chain. Okay. And external secure logging services, sending the logs to some trusted or some offsite services immediately. So local compromise doesn't help an attacker. Okay. Immutable logging framework. So some systems like certain cloud providers offer built-in support for immutable audit logs. Example of the technology is that AWS Cloud Trial with some log file integrity or some sign that security information and event management with some tamper evident features and blockchain based audit logging solutions and Linux audit with remote login shipping and cryptographic validation. Okay. And apart from that, we will say that there are like more detailed audit logs like encryption in transit and at rest. So encrypting log data both while it's being transferred and when stored on the system protects it from unauthorized access and modification. And what about keystone protection is that using a certificate stored in a keystone, only those with the correct password can view or update the encrypted audit logs. And what about digital signature is that? So here log signing audit logs ensures that any changes made can be traced, making it easier to detect the tampering. And unique fingerprints like digital signature provide a unique fingerprint for each log entry, allowing for easy detection of modifications. Access control and authentication is that centralized logging. So using a centralized log management system with some strong authentication and access control, which restricts who can access and modify the audit logs. Okay. And least privilege. So granting users only the necessary access to audit logs minimizes the risk of unauthorized modification. And other techniques like log rotation and retention policies. So regularly rotating and storing logs in a secure location, which prevents the long-term tampering, and monitoring and auditing logging activities. So monitoring the logging process itself helps to detect and respond to any unauthorized attempts to modify the audit logs. And blockchain-based logging, so utilizing blockchain technology can create some immutable and verifiable records of events, making it difficult to tamper with. Hashed log entries, like including a hash of the previous log entry in each new entry, provides a chain of verification, making it easier to detect if a log has been modified. And then timekeeping services. So combining log hashing with timekeeping services like the Bitcoin network can create a timestamp that is impossible to alter without the detection. And specific examples is that ServiceNow Protected Tables plugin. So this plugin allows you to prevent log tampering by blocking or logging attempts to modify the audit records. And Dell PowerMax audit record. So these logs are designed to be tamper-proof, internal, secure, and inaccessible to any user, regardless of their access level. And hard log. So this system uses a novel audit service to provide fine-grained log protection, ensuring that security critical events are synchronously protected. Okay. So by implementing these kind of techniques, organizations can create robust audit records that are resistant to tampering, ensuring the integrity of the security and compliance records. And before going for the techniques, I'll just say some small example for the tamper-proof audit logs using some hash shaming and signing. Like the basic concept is that first you have to every log entry is hashed. Each entry also stores the hash of the previous entry to create a chain. So the final log file or the every batch is signed with the private key. So example is that first you have to set up your basic log format, like you have to set the timestamp or the user like Alice or the what action that he is going to log in, and previous hash plus the current hash. Okay, so create a simple script either in Python or Java to generate some chained logs. Okay, for the first log entry you have to initialize some value and have to create a log entry, and you have to create the hash of the log data by using some JSON file, and you can use some hashing algorithms like SHA-256, SHA-512, and you have to add the current hash to the log data. And example usage is that like you can go for some log entry previous hash. Okay, so this will produce something like the timestamp Alice action previous hash versus the current hash, and then you have to sign your logs. So after you write a batch of logs to a file, you can sign the entire file using a private key by using OpenSSL, by using the digital signature or the PEM file. You can just go for the private key and the public key, and later the auditor they can verify the signature by using some verify public key or the PEM signature. So what happens is that initially we are creating a log entry that includes the previous hash. We are storing entire securely append1d file or database that is write once, and regularly sign batches of logs and store the signature separately. And audit by checking the hashes and verifying the signatures. And extra options you might consider is that you can ship the logs immediately to some remote secure server, and you can go for some blockchain or append only database like AWS QLDB and encrypt the log if they contain some sensitive data, and enable the timestamping services with RFC 3161 for independent proof of timing. Okay, now let us discuss on the topic called techniques to implement the tamper-proof log. So the first one is that cryptographic hashing. So what is the cryptographic hashing? So each log entry is hashed. A chain of hashes is used like a blockchain, like h plus h of entry of n minus 1. Okay, and then followed by the digital signature. Okay, and so digital signatures, the logs are signed using the private key. So verification is possible using the corresponding public key, and you have to ensure the authenticity as well as the integrity. And write once or read only, read many storage is that warm storage. So here hardware or software enforced storage where data cannot be modified after being written. So used in compliance heavy industries like example like SVCE or HIPAA, and blockchain distributor ledger like decentralize and append only, and each node maintains a copy. Tampering one node doesn't affect the consensus. And third party logging services, you have to send logs to an external service that is out of the reach of local attackers. Example, AWS CloudTrail, Splunk, ELK stack with strict access control and access controls and monitoring. You have to limit the access to logs using RBAC, that is role-based access control, and you have to alert and monitor for suspicious access or some modification attempts. Okay, so these are the techniques involved in tamper-proof technique. So other than that, techniques involved in tamper-proof audit logs is that so there are so many audit tamper-proof techniques. So first one is that, as we told, hashing, hash chaining, so cryptographic sign, and then right one, so it is a immutable storage, okay, and then time stamping, and then one more thing is that remote log, that is a offsite storage we used to say. So logs are immediately shipped to a separate secure server or external services. Purpose is that if a main system is compromised, attackers can't also modify the historical logs. And there is one thing like blockchain, this yeah, discussed already, and anomaly detection and logs. Automated system monitors for some suspicious gaps, duplicates, missing entries, or modified hashes. Early detection if someone tries to alter or bypass the logs, and versioning, like a system can store all versions of a log file. Example, the cloud system with versioning enabled. So purpose is that if overwritten previous versions, so there it can't be previous for cynic investigation. Okay, and real-time example like hashing and chaining if you are using is that example technologies like custom scripts or the blockchain, and signing like open SSL or PGP, and write one storage you can go for like AWS S3 object block, Azure immutable blob, or secure timestamping like RFC 3161 timestamp authority, and remote logging like system to remote servers Splunk ELK, and you can go for some Hyperledger Fabric or the customer blockchain logging. Okay, so this is the tamper proofing audit log. So as we have discussed in the previous slide, so here, like say for example, he is Alice. Okay, like you can consider, so he is Alice. So this Alice, he'll be just giving once he is logging the particular system, it will be specifying the date, like which date he has logged in, like which time. Okay, and if he user a like Alice is logging in, and the previous hash will be displayed, and based on that the corresponding hash value also will be displayed. Suppose like user A, he has deleted the record 123. Okay, at that time also he can be going for the hash value, the same hash value, but with a different hash functions. Okay, so this is what, and once he is logged out, he will be just retrieving all the data which has been used, and then he'll be coming out. Okay, so this is all about the tamper proof audit log, a simple diagrammatic representation. Okay, and next we are going to discuss is about advantages of tamper-proof audit like logs. So first one, ensures data integrity. So each log entry is cryptographically linked to the previous one. Any alteration becomes immediately detectable and enhances security. So here, protects against insider threats and malicious tampering, acts as a deterrent for unauthorized modification, and facilitates a trust and transparency. So builds the confidence with stakeholders, auditors, and clients, and useful for some regulated environments like finance, healthcare, and defense. Okay, and This is about facilitates and transparency. Next one is that supports regularity compliance. Okay, so here it meets the requirement for standards like HIPAA, that is healthcare, and SOX, that is finance, and GDPR, that is data privacy, and ISO 27001, that is used for security, and reliable forensic and instant response is that so provides verifiable chronological evidence during investigations and helps to trace the root cause of breaches or the misbehavior and prevents a denial of action is that which is otherwise called as non-repudiation, which we have seen in the first one, that is cryptographic hashing, all those stuff. And here users cannot deny the actions since logs are securely recorded, and it is useful in some legal disputes or some audits. Okay, and last one is that which enables automated verification. So logs can be validated automatically using the hash check or the digital signature, which reduces the manual inspection. Okay, so these are the advantage of tamper-proof audit logs. Okay, and if you are going for some real-time example for tamper-proof audit log, yes. So there are so many things like uh, tamper-proof or ignore some identity data. Okay, and where blocks should be protected from unauthorized access or protected from unauthorized copying or exfiltration. In India and Estonia, for example, dogs are digitally signed to detect some tampering. In addition, chaining digitally signed logs in Estonia, the particular country, which makes it difficult to change the history. So, using some emerging technologies like blockchain or its potential to increase the security of these kind of logs by making them immutable even to the agencies that maintain them. Okay. In addition to facilitating audits of data use, logs are of vital importance in instances of fraud or security breaches as they will form the basis of investigation or review of system activity and data access. So the tamper-proof nature of the logs is also crucial as attackers who gain access to the underlying IT system may attempt to alter or delete this information. So, it is therefore important to put in place systems and technologies that minimize the risk of such attack and ensure the integrity and security of audit logs. And such as ensuring that logs from application servers or remote as soon as possible and sent to a central log management system. If possible, sending log data directly to a centralized log management system and make sure that log files or log transactions are encrypted in transit and then rest. So ensuring that the centralized log management system has sufficient access control and authentication as well as access audit logging and applying role-based access to some log file system to ensure that only authorized personnel may perform some actions such as deleting the log files and analyzing the log file activity to identify the gap in logging or patterns of corruption which may highlight some suspicious activity. Okay, like a tamper-proof lock which I discussed in Estonia. So here, the personal data usage monitor, that is an open source software, filters and logs the transaction containing the personal data. So it is used at the exit points of information system from where the data flows to the other systems. So this independent software can capture the transactions containing personal data based on the rules defined to identify personal data traffic flowing out of a system and log them with some timestamp and digital signature. So suppose there is an institution A and institution B. From institution A, there will be some external security server, some extractor or info system A, or like the open source software. Okay, and then the internal user will be trying to access a portal. So the ID owner, what he'll be doing is that from the external security server, he can able to access to the portal. And from institution B also, the external security server will be trying to provide the data. Okay, so these are accessed to the users via like, the citizen portal which they are gonna use. Okay, so this is all about the advantages of tamper proof audit logs. Okay, and what is called as cryptographically signed audit log? Does anyone know? I'll just discuss on it. So audit trial is some log records which is in chronological order, which identifies a source and a reason for a log and provides relevant context for some further investigation. And audit logs contain information about access management events, like sensitive actions made by the users, event from the services, as well as the critical errors. So as the audit logs become the security sources of trust, they require some protection. So in many cases, audit logs are available to super users only, which is stored in some special storage and backed up. So however, as logs or just text messages, they require a set of some security procedures and often become an easy target to manipulate as well as tamper. Okay, so like there will be somehow crypto or blockchain is formed is that. So log entry will be there, some integrity check will be available. So LE1, LE2 or 2 LEN will be there. And audit blockchain like IC1, IC2 till the ICN will be available. Okay, like Orilog security in ACRA is there. So ACRA is a database protection suite that provides tools for protection data that is stored in the database like on-the-fly encryption and detection, data pseudonymization and masking search through some encrypted data, etc. Okay. And acrologs contains information about the application and database connection attempts. So API usage of key management actions, data processing events, and all those stuff will be there. And what about security requirements towards cryptographically signed audit logs is that so log messages in each log entry should be protected against the tampering or the symbols editing. So the structure of the log chain should be protected against some modification or adding or removing separate log entries. Log chain should be protected against some truncation attack when logs are truncated from the end of the chain. So crypto signed audit logs should be initialized as early as possible at startup of logging service to reduce the number of unprotected log entries in the log chain. Okay, and service restart and shutdown should not lead to some inconsistent audit logs. And if a service was shut down due to some emergency or some audit logs, it should be verifiable. And key security is that a cryptographic key that is used for some computing integrity checks should be stored in some dedicated key storage and reside minimum time in service memory. Okay, and acceptable performance the ability to verify the production volume of protected logs in seconds, which performance directly affects the instant detection and reaction time, that's MTTD and MTTR. The verification of audit logs is an automated monitored procedure. So log rotation friendliness like audit logs should be compatible with log rotation policies typical for some distributed system. Okay. Okay, so we have seen the various advantages of tamper-proof audit logs, and in each audit log there will be some message, date, action, error code, right? So for each log entry, we have to add integrity check computed by iteratively following the formal principle. Okay, so audit log chain, the basic hashing which we have done in SHA-256 or 512, all those stuff will be related for this thing. Okay, so the next topic we are gonna see is the drawback or the disadvantage of the tamper-proof audit logs. The first topic is that increased complexity and management overhead. Second one, potential for false positive and missed incident. Third one, challenges in auditing and compliance. Fourth one, data privacy and security concerns. Last one, impact on incident response. So what about increased complexity and management overhead is that? So data volume and complexity, like tamper proofing often involves more extensive log generation and storage, making it harder to manage and analyze the vast amount of data. So expertise required is that implementing and maintaining some tamper-proof system often requires some specialized knowledge and expertise in some security, logging, and data management. So cost is that the development, deployment, and ongoing maintenance of some tamper-proof system can be costly, especially for some large organizations. And potential for false positive and missed incident is that a noise and false alarm, so tamper-proofing can lead to an increase in false positive, making it difficult for analysts to distinguish between the legitimate activity and actual security breaches. And missed incidents is that overly complex or poorly configured tamper-proofing system can inadvertently miss important security events, hindering timely instant detection and response. And challenges in auditing and compliance is that so difficulties in navigation and storage. So as log data grows, it can become increasingly challenging to navigate, search, and store, particularly with some more granular and detailed logs. An inconsistent log format is that so different system and application may use varying log format, making it harder to consolidate and analyze the data across the different sources. And data privacy and security concern is that so privacy issues like tamper proofing can inadvertently capture some sensitive user data, so which can raise privacy concern and require careful handling and compliance with some data protection and regulation. And security risk is that so while a tamper proofing uh, aims to protect the logs, it's important to ensure that the systems implementing these measurements are also secure and not vulnerable to attack themselves. An impact on instant response here, a delayed response or complexity of some tamper-proof system and the potential for false system can slow down some instant response, so potentially allowing malicious actors to continue their activities for longer. Okay, and reduced agility. So here, overly rigid or complex tamper-proofing system can make it harder to adapt to changing the security threats and vulnerability. So while tamper-proofing audit logs is essential for security and compliance, organization must carefully weigh the benefits against the potential drawback and ensure that the implementation of such measures is well planned, managed, and optimized for some specific needs and resources. Okay, so this is all about the drawbacks of tamper-proof audit logs. So the next topic we are going to see is that quality of service. So quality of service refers to the technique used to ensure a specific level of service and compliance for applications and users, some accessing some cloud resources which is available. And this includes like factors like availability or reliability, response time, and throughput. So QoS aims to guarantee that critical applications receive the resources they need even when network resources are limited. Okay, so this is all about the quality of service. So next we are going see is that before advantages, I'll just explain about the, so what are the key aspects of QoS in cloud? So performance metrics. So QoS is assessed by some various metrics like latency, jitter, packet loss, and bandwidth availability. And traffic prioritization. So QoS mechanism prioritize network traffic, ensuring that high priority applications receive the necessary bandwidth and resources. And resource allocation is that, like, QoS can be used to manage some and allocate resources such as CPU and memory to virtual machines or applications. And service level agreement is that, so QoS is a crucial element in SLA, ensuring that cloud providers meet some agreed upon some services levels and performance expectation. And what about user experience is that, so QoS directly impacts the user experience, and thereby it will ensure that application perform as expected even under load. Okay. So this is about QoS in cloud. I will just say one more thing. So what are the advantages of QoS in cloud? So first one is that performance guarantee. Second one, better resource allocation. Third one, enhanced reliability. And the fourth one, monitoring and predictability. And next one is that improved user experience. And next one, supports multi-tier services. Okay, so these are the advantages or the major advantages we can see. And apart from that, like there are some benefits which ensures, like improved application performance or enhanced user experience, cost optimization, scalability, as well as flexibility. Okay, so here the first point is that we're going to discuss is about a performance guarantee. So it ensures that a minimum level of CPU or the memory or the bandwidth or IOPS is used, and prevents uh, the resource starvation in multi-tenant environments, and better resource allocation. So here, QoS policies helps to prioritize critical workload, which enables fair resource sharing and avoids noisy neighbor issues, and enhanced reliability and availability. So it reduces the likelihood of system failures or service degradation, and supports SLA by maintaining some consistent performance, and monitoring and predictability, which ensures a better control and tracking of resource usage, and provides metrics for auto scaling and forecasting, and improved user experience, so low latency and high throughput for the end users. Okay, and especially it's critical for applications like video streaming, gaming, or some real-time analytics, and supports multi-tier services, which allows for setting some different QoS levels for various services, like example gold, silver, or bronze tiers, and customers pay for the level of security they need, and security and isolation, which helps contains workload, so one tenant burst doesn't affect the others, and contribute some virtual isolation in shared infrastructure. Okay, so apart from guaranteeing certain performance level for services like speed, availability, throughput, latency, and error rate, so cloud providers like AWS, Azure, GCP, it also uses some QoS techniques to prioritize some important workload which allocates the resources and meet the SLA promised to some customers. And some examples like networking, prioritizing video calls over the download, so calls stay smooth. In storage, like faster SSD for some critical databases. In compute, some guaranteeing CPU and memory for a premium app if you're gonna use it. Okay, and key QoS techniques is that, like traffic shaping and controlling the data flow, and resource reservation, like dedicating CPU or the memory bandwidth, and load balancing, like distributing work evenly, and auto scaling, like adding or removing the resources automatically. Okay, So that all comes under thing. And if you take in cloud services, like it's a basic of cloud, right? In cloud services, if you take what kind of QoS it affects is that mainly focuses on ensuring performance, reliability, and availability for the users. Like SaaS, that is software as a service, like example, Google Workspace, Salesforce, or the Zoom. So QoS ensures apps stay responsive even if lots of users are active. So techniques like a load balancing or across the server, multi-tenancy optimization, isolating heavy users, data caching to reduce the delay, and PaaS like platform as a service, and QoS ensures developer apps run smoothly without worrying about the infrastructure, and techniques like auto scaling based on some app usage and prioritizing workloads for some mission critical apps, and service monitoring and fast recovery after the failures. So infrastructure as a service is that AWS EC2 and Azure VM. So QoS ensures the raw infrastructure, VM storage, networking meets a performance deep. So techniques like SLA for the uptime or downtime you can go for it, but uptime is used like nearly 99.9% is available. And for tire storage operations is also used. And like how cloud providers manage the QoS is that like SLA agreement, like promise a certain level of performance. Example, 1 millisecond latency, like 99.999% shutdown, and monitoring and analytics, like detecting the bottlenecks, early like CPU spike or slow DB calls, and fault tolerance, like a backup system and regions in case of failure, scaling up or down automatically with some demand, right? So in short, I can say that QoS in cloud services is all about balancing many users and workloads. So while keeping the apps fast, reliable, and secure. Okay. If you take what are the major drawbacks? Yes. So drawbacks is that so these are the major challenges like dynamic environments or the resource allocation or network congestion, and then security. Okay, so first one is that dynamic environment. So here the cloud environments are dynamic, right? With some resources and users which constantly changing, which can make it changing to maintain some consistent QoS, and resource allocation. So determining the optimal resource allocation for some different application and users can be complex, requiring some careful consideration of the specific needs and prioritize. And network congestion like can impact some QoS, requiring effective traffic management and prioritizing strategies. Okay, and security, it ensures the security of cloud resources while maintaining the QoS can be challenging, but it requires a careful consideration of security protocols as well as resource allocation. And if you take in case of cost, that is also one of the challenge. Like it has some higher level of QoS levels like guaranteed low latency or often like mean higher prices like premium services which can get expensive. So even some strong SLAs outages still happen. AWS, Azure, GCP all have had the major downtimes, and guaranteed performance is still the best effort during some extreme traffic or the failures. And resource contention in shared multi-tenant environments, so noisy neighbors, heavy users, they can still affect your performance unless strong QoS isolation is done. And monitoring overhead, so that is also one of the drawback. So here it constantly monitors and enforces QoS ads, which is extra processing and management effort. So performance degradation in peak times, like during some sudden spikes like Black Friday sale or some viral events, QoS mechanisms might struggle to prioritize everything properly. So like QoS helps a lot for us, but it's not a magic, right? It costs more, adds complexity, and still can't 100% protect from some big failures. Okay, so that is one case. And If you take some real world examples of this QoS, or this is all about challenges, and it's like real world examples like AWS S3 outage, which occurred in the year Feb 2017. So what happened is there, like Amazon's S3, the simple storage service in the US East 1 region, went down for impacts, like hours and hours. So what is the impact is that so thousands of websites, apps, and services relying on S3 failed, like Trello, Slack, Cloud, Square, etc. And the QoS price, so even though the AWS promised high availability, a tiny typo during maintenance caused cascading failures across the storage system. So showing that QoS cannot prevent some human error, right? So that is one thing. And second example, like if you're gonna use some Microsoft Azure multi-region outage, which occurred in the year 2019. So what happened is that a lightning strike took out cooling systems in a major Azure data center in Texas. And impact is that multiple services, VMs, databases, etc. across the southern US went down for hours. So although the Azure had disaster recovery plans, the sudden loss of cooling led to hardware shutdowns faster than they expected. So overwhelming backup system. And Google Cloud networking outages that which occurred in the year June 2019. So here what happened is that a configuration mistake in Google's network caused huge congestion affecting the Gmail or YouTube or Google Cloud services and even third-party apps like Snapchat. Okay, so QoS failure, like a network QoS couldn't prevent traffic bottlenecks because too much priority traffic flood or limited some remaining routes. Okay, and another thing which occurred in the year 2020 is like Zoom cloud issues during COVID-19. So when the pandemic started, Zoom's cloud services running on AWS and Oracle faced extreme demand spikes. So video quality dropped, connection failed, and users experienced delays. So although scaling mechanisms existed, the 730x user growth overwhelmed elastic QoS scaling model. And in 2021, a DNS, a Salesforce actually, a DNS issues is occurring in Salesforce to become some unavailable which for many users, and CRM services and support for platforms and other Salesforce dependent apps were unreachable. Even critical services can be vulnerable if core network components like DNS fail because QoS doesn't fix some broken routes, right? And even the biggest, most redundant cloud setups can break under some human errors or some unexpected traffic spikes or natural disaster or hardware or some network failure. So QoS can be, minimize the risk, right? But you can't able to eliminate that kind of risk. So this is all about the QoS. So in this particular video, we have discussed about the tamper proofing, audit logs, and then what kind of we have discussed what type of techniques it is used and where it is used and what kind of advantages, disadvantages, and we have seen some real-time examples for tamper proofing or like based on some hashing methods. And also we have discussed on the topic called QoS, that is quality of service. So here also we have seen some key aspects of QoS cloud, advantages of QoS, drawbacks of QoS, and key aspects of QoS and how to overcome these kind of issues in the real-time world, and we have discussed there are some real-time examples too. So these all comes under the QoS. I hope you might have a clear view on these two topics. So we will see in the next video. So thank you all.